All right, guys, happy Friday. I was going to talk like Dracula like this because it's so close to Halloween, but I don't think I could keep it up for the whole thing, so that's it. All right, chapter 6, Similarity. This is lesson 6.0 about ratio and proportions, problem solving. Uh-oh, it's going to have to involve words, I bet. All right, first off, let's review a ratio. The ratio of A to B, if A and B are two quantities that are measured in the same unit, then the ratio of A to B is A to B. You can write it like that, like a fraction, okay? A proportion is an equation that equates two ratios, right? A to B is equal to C to D. All right, you guys did that review packet, yes, or not packet, couple problems yesterday. Cross multiplying, the stuff you learned in algebra, easy peasy. Well, we're just gonna expand on that. Let's take a look here. All right, so let's just review some of these examples with two proportions, okay? Remember, we cross multiply, so I multiply this way on the diagonal. 7 times x gives me 7x. Then I multiply this way. 2 times 21 gives me 42. When I divide both sides by 7, I get x is equal to 6. All right, cool beans. All right, so now 2 is just like a little more intense because now when I cross multiply this way, I have to what happens here is like 4 times 3x minus 12. So you have to make sure that you're distributing to both terms there, okay? So 4 times 3 is 12x. 4 times 3x is 12x. 4 times negative 12 is negative 48. And we put our equal sign and we cross multiply the other way. 6 times x is 6x. All right, typically I like to move my variables to the left side, but in this case I already have negative 46 there, so I'm going to move my variable term to the right side. I'm going to subtract 12x from the left and bring it over to the right. Cross it out. Negative 48 is equal to negative 6x. All right, one last step, just got to divide both sides by negative 6. And we get x is equal to 8. Fantastic. All right, nice. Let's look at this next example, number 3. Just kind of like number 2. All right, we cross multiply. 3 times t plus 4. 3 times t is 3t. 3 times 4 is 12. All right, then I put my equal sign and I cross multiply the other way. 8 times t is 8t. All right, cool. I try to make my t's with that little curly thing at the end so it doesn't look like a plus sign, but I'm sure you guys are doing great, taking awesome notes. All right, we subtract 3t from both sides because you know how to solve equations by now. You're masters at it. 12 is equal to 5t. Uh-oh, I'm not really liking the way this is going. So what do I got to do? I got to divide both sides by 5. Well, if you're thinking 12 is not divisible by 5, you are thinking correctly. This is just going to be t is equal to 12 over 5. Hey, fractions happen, right? If I asked you to round to the nearest tenth, you'd put that in your calculator, divide, and then round to the 1 decimal place, right? 1 decimal place to the right. All right. That's just a review of proportions. Let's talk about setting up a proportion so we can solve problems. All right, number 4 says a scale model of a car is 10 inches long and 5 inches tall. The actual car is 60 inches tall. What is the actual length of the car? That is what we're looking for, the real length. Let's set up our proportion because we have two ratios here, right? We have the ratio of the car's length over the car's height, right? So if I write length here, and then I have height here, right? I just want to make sure that when I set up my second proportion that I keep length in the numerator and height in the denominator. It's extremely important when you set it up. because it has to be, you know, we're setting up a proportion, it has to be comparing the two quantities. All right, so let's see here. The actual car is 60 inches tall. Well, 60 inches tall is the height. That's going to go in the denominator. And I want to know what the actual length is, so that's going to be my variable. That's going to be my x. All right, now we're just going to cross multiply this little beauty. I'm going to rewrite it a little bit here. 10 over 5 is equal to x over 60. If you were so inclined to reduce, you could, but I'm just going to roll with it. 5 times x is 5x. And it really doesn't matter which way you start when you cross multiply. If you want to go up from the left or you want to go up from the right, whatever you want to do. And I cross multiply here. 10 times 60 is 600. Divide by 5. And I get x is equal to 120. One thing I want to remind everyone is to always make sure you use your units, okay? So the actual car is 60 inches long, so now the actual length is 120 inches. So it's 120 inches long. Oh, and I meant 60 inches tall. I'm not sure if I just said long. See what happens when you talk and write at the same time? You write weird stuff. All right, inches is I-N. All right, so the car is 120 inches long. All right, that's not too bad. That was pretty easy setting up that proportion to solve that problem. Let's see another one. All right, this problem that I have here is about perimeter. The perimeter of a rectangle is 56 centimeters. The ratio of width to length is 3 to 4. Find the width and the length. All right. So first, let's refresh our memories. The equation of perimeter. Perimeter is equal to 2 times the width plus 2 times the length. Because remember, a rectangle has 2 long sides and 2 short sides, right? It's a quadrilateral, right? So it has 4 sides. So we have 2 times the width plus 2 times the length. All right, so now how are we going to set this up? First off, whenever you have a situation like this, it's 3 to 4. I want you to always know that what you're going to do is you're going to be like 3x is the width and 4x is the length. That's what gives us that 3 to 4 ratio, because when x is the same number, that's what's going down, okay? So what I'm going to do with this is I'm going to plug this in for my length, right? And I'm going to plug this 3x here in for my width into my fancy equation. Now, I was given the measure of the perimeter in the very beginning, right? The perimeter of the rectangle is 56 centimeters. So we replace P with 56. And now we know the formula is 2 times the width, but the width is 3x, plus 2 times the length, and the length is 4x. And now we're ready to solve away, because we're masters at solving equations. Let's do it. All right, 2 times 3 is 6x, plus 8x. All of that equals 56. 6 plus 8 is 14. All right, and then we just divide both sides by 14. And I get 4. 4 is equal to x, or x is equal to 4. All right, that is half of the problem. What I need to do is I need to plug 4 back in to both of my widths and lengths, right? We're going to plug that back in. So the width is equal to 3 times 4, which is 12. We're talking about centimeters here, so make sure you write your units. It's important. And the length was 4x, but we know that x is now 4. And 4 times 4 is 16. So this rectangle was 12 centimeters. Oh, let me change the color here so it stands out. I use bright red. All right, so the width was 12 and the length was 16. Oh, and I didn't put my units. See, I'm always saying, use your units. All right, but really this is the answer to the question. I was just showing you the little image. All right, easy. Look at that, ratios. Well, we didn't even need a ratio for this one, but we needed to understand that when something is given in a ratio and we don't know what that value is, but that we do know that it's a 3 to 4, you always follow it with the same variable. You could use a different variable. You don't have to use x. All right, let's take a look at another example, a little similar but slightly different. All right, this last example, well, maybe it's not my last example. I might have another one after this. I don't want to lie to you. I do. I have one more after this. All right, so number 6 says the measure of the angles in a triangle are in an extended ratio of 1 to 3. All right, so let's refresh our memories about a triangle. Remember, the interior sum of every single triangle is 180 degrees. All right? If the ratio is 1 to 3, right? In order for that to happen, we have 1x, 2x, and 3x. That's what gives it the ratio, right? X is the same number. Now I have a 1, 2, 3 ratio. Remember, the interior sum is 180 degrees, so we can set up an equation. So 1x, and I really never usually write 1, but I'm just going to do that for now. 2x plus 3x all equals 180. So we combine like terms, and I have 6x, excuse me, is equal to 180. Divide by 6, and I get x is equal to 30. All right, so that was awesome. Now I just need to make sure we find the measure of each angle. We need to answer the question. All right, so if x is 30 here, this is 30 degrees. And if x is 30, this is 60 degrees. And then here, 3 times 30 is 90 degrees. So my measures are 30, 60, oh my God, and 90 degrees. All right, so that is answering the question. Beautiful. All right, last one, I swear, last example. We are again talking about a rectangle, but this time we're talking about area. The area of a rectangle is 96 inches, square inches, excuse me, because remember, area is always units squared. The ratio of length to width, or width to length, is 3 to 1. Find the length and the width. All right, so let's refresh our memory. The area of a rectangle, the formula for area is equal to length times width. That's my little multiplication sign there. Just to refresh your memory. Length times width. Not too bad. All right, remember what I said when you see a ratio like this? So you know that the width, right, is the 3. So the width is 3. And the length is 2. In order for them to have a 3 to 2 ratio, we're just going to put that x here. Because x is some number that's going to make that happen, right? The same number. All right, let's go ahead and solve this. So 96 inches squared is equal to 3x. Oh, well, yeah, I'll write it. All right, the length was 2x, so 2x times 3x. 2 times 3 is 6x squared. Still equal to 96, right? Divide both sides by 6. 96 divided by 6 is 16. Equals x squared. In order to unsquare x, remember you got to take the square root of both sides. And I get really plus or minus 4 here. Plus or minus 4. Oh. Is equal to x. But what, logically, like think about it. So if we plugged in a negative 4, 3 times negative 4 would be negative 12. There's no length, there's no rectangle, nothing with a side that has negative 12 inches long. So we're only going to use the positive 4. So x is equal to 4 because that's what makes sense. All right, when we plug that in, 3 times 4 is 12. Remember, we are talking about inches, so it's going to be inches. And 2 times 4 is 8. All right, so the width is 12 inches and the length is 8 inches. It seems like the width is longer, but the width had a bigger ratio, right? 3 to 2. Boom, done. Easy peasy lemon squeezy. So set up a proportion when you can. If you see this funky little ratio, just follow it with a variable and make sure you're paying attention to whatever formula it is. In this case, it was area. Previously, we had perimeter. So if you have any questions, make sure you send me a message on Schoology because I check it all the time. And here is your assignment. Worksheet number 29 to 44. That's not true. Hold on a second, guys. That's craziness. It is actually worksheet ratio and proportions. But you know about it because it's already in Schoology. So make sure you do every problem. Try to show all your work and have an awesome weekend. See ya.